Okay, guys, let's take a look at the chapter 21 homework. So let's start here with question 1. Whoops, that was question 2. Let's go back to question 1. Okay. Suppose an advocacy organization surveys 817 citizens of country A, and 403 of them reported being born in another country. Similarly, 20 out of 122 citizens of country B reported being foreign-born. Find the standard error of the difference in the two proportions. Okay, I paused the recording because I wanted to bring up our formula for this from the notes. So if you go to the chapter 21 slides, this first slide right here shows you that standard deviation. So the standard error is the same thing with our samples. All right, so notice that it's the square root of P1 Q1 over N1 plus P2 Q2 over N2. So let's go back to our problem here. So our first item here, the P1 hat, would be the citizens from country A. So it's 403 out of 817. And P2 hat would be 20 out of 122. All right, so now if we pull up our calculator, I'm sorry, I need to make this just a smidge smaller so I can get to that calculator. Do it this way. Stop that. Okay. I can't pull up my calculator easily. There we go. Now I can get to the calculator. Okay, so let's clear what's on there. Okay, so we had the square root of, and then it was P1, which is 403 over 817. Oops, parentheses, 403 divided by 817. Times Q1. Now Q1 is 1 minus that. Q1, so that would be 1 minus 403 over 817. Close the parentheses for the Q1. And then we want to divide all of that by the N1, which is 817. And then add to it. Now we're doing the same thing with the opposite one. So we're going to go 20 divided by 122 times its Q would be 1 minus 20 divided by 122 over the number in its sample is 122. And then close what's under the square root. And we get a 0.0378. So we want to go to 4 decimal places. So that was 0.037. 1, 2, 3, 4. So yeah, an 8, because after it is a 0. All right. Let's clear that. All right. Suppose that a survey finds that 75% of adults visit a certain website on a daily basis, up from 52% in the same survey taken 3 years earlier. What does it mean to say that the difference in proportions is significant? Okay, the differences between the sample proportions are not, we're trying to say that the difference in the proportions is significant, so I'm not sure why they threw that first sentence in there. It is very unlikely that samples would show an observed difference this large if in fact there is a real difference in the proportion of adults who visit the website daily. That's not quite phrased right, but almost there. It is very unlikely that samples would show an observed difference this large if in fact there is no real difference in the proportion of adults who visit. And this is what we mean, right? If it actually hasn't changed, it would be really weird to get a sample that large. That's what you're trying to say by saying that the difference in the proportions is significant. A political candidate runs a week-long series of TV ads designed to attract public attention to his campaign. Polls taken before and after the ad campaign show some increase in the proportion of votes who now recognize this candidate's name with a p-value of 0.176. Is it reasonable to believe that the ads may be effective? Well, 0.176 is actually a high one, right? So no, there is not sufficient evidence to show that TV ads are effective because the p-value is greater than a reasonable level of significance. Like if our alpha is 0.05, right? This is much bigger than the 0.05. 886 randomly sampled teens were asked which of several personal items of information they thought it okay to share with someone they had just met. 44% said it was okay to share their email addresses, but only 29%. Okay, I guess I can't do that. But only 29% said they would give out their cell phone numbers. A researcher claims that a two-proportion z-test could tell whether there was a real difference among all teens. Explain why that would not be appropriate for that data. Well, notice that I'm measuring two different things here. In the first case, I'm measuring whether I'm going to share my email address, right? And in the second case, I'm measuring whether I am going to share my cell phone number, right? So the responses would not be from two independent groups because we're asking the same people, right, to share two different items. A survey was taken of randomly selected Americans aged 65 and older, which found that 413 of 1,020 men and 534 of 1,059 women suffered from some form of arthritis. Are the assumptions and conditions necessary for inference satisfied? Okay, so it was a random sample. Yeah, it says randomly selected, less than 10% of the population, but these numbers are less than 10% of all men and women, right? The groups are independent, men and women, and there were more than 10 successes and failures in each group, 413 and 534. So yes, we're good. Create a 95% confidence interval for the difference in proportions of senior men and senior women who have this disease. Okay, now let me see what I can do here. I could use my confidence interval formula that you have right here, but we can also do it very, very quickly on the calculator. And I really wish I could make it smaller. As you can see, I've been struggling trying to get that window to minimize. You need to pause the recording to be able to do it. Let me do that. Okay, I apologize. I don't want to take up too much time trying to adjust this. I can't get it to adjust, so we'll just have to deal with the inconvenience of it. But okay, so over here, let's move this to a better place then. That would be good over here. Okay, so we're going to go to stats and over to tests. And we're doing a two proportion z-test. And our x1 is 413 out of the 1020. So 413, and then that's 1020. And our x2 is 534 out of 1059. And we're trying to do, oh, I'm sorry, I'm trying to do a confidence interval. I didn't mean to choose the hypothesis test. So let's scroll down and find our, two proportion z interval right there, option B. Okay. So 413 out of 1020 and 534 out of 1059, it's 95%. And calculate, we get negative 0.1419, round to 3 decimal places. So negative 0.142. Come on. What's the problem here? All right, let's try getting out of here and going back in. Maybe that'll cure a bunch of problems. So let's go back into that one. Our numbers might change here. See, and it resized itself correctly. Okay. Our numbers the same, 413, 1020, 530. I think that is the same. So we're going to go negative 0.142. And then the positive is negative 0.057. Now, by the way, the fact that these are both negative tells me that this second one is bigger, right? So we would think that the women suffered from arthritis more than the men. What do you mean my answer is incorrect? Let's try that again. Let me double check what we put in there. T proportion C interval. 413 out of 1020, 534 out of 1059, and it's 95% confidence for the difference in senior men and women who have this disease. Oh, I'm sorry. No, wait, that should be right. Let's see. What's going on here? 0.142, 0.057. P1 is women. All right, so they have this backwards. All right, so I put men in first, but they wanted the women in first. This is why we should pay attention and read the question. So we could redo the whole thing, but just make it positive and reverse the numbers. Because we're just subtracting in the opposite order. 0.142. There we go. Just make sure that you read the question. I didn't see that the women were coming first. There is 95% confidence based on these samples that the proportion of American women aged 65 and older who suffered arthritis is between 5.7% and 14.2%. I'm just moving the decimal over 2 places here. Greater than the proportion of American men. Does this suggest arthritis is more likely to affect women than men? Yes, the entire interval lies above 0. Remember, and this is the question that you had on your discussion and all, when 0's in the interval, they could be the same. That's the key thing you're looking for here. In 1997, researchers investigated the effect of weed-killing herbicides on house pets. They examined 813 cats from homes where herbicides were used regularly, diagnosing malignant lymphoma in 420 of them. Of the 133 where no herbicides were used, 20 were found to have lymphoma. What is the standard error of the difference in the two proportions? Okay, so we can use our formula again to get that standard error if we like. So our P here is the 420 out of 813. So I'm going to go 420 out of 813 and then 1 minus. So this is times 1 minus 420 out of 813. And then divide that number by 813. Then plus do the second fraction. And the second fraction is 20 out of 133. So 20 out of 133 times 1 minus 20 out of 133. And divide that by the 133. And we get 0.04 decimal places, 0.0356. 90% confidence interval. So we're going to go stat, tests, option B. And this time we have 420 out of 813. And my other one is 20 out of 133. And this time we want to be 90%. So that was 0.308 to 0.425. Select the correct choice. Okay, there is 90% confidence that lymphoma rates of pets is greater in homes where herbicides is used by an amount from. Oh, I was trying to look for the difference between the first sentence and the second sentence, and I see here it's pets and here it's cats. That's the only difference in the wording. Our sample was only on cats, so I can only generalize to cats. From 0.308 to 0.425. They didn't prompt me for a percent sign there, so I assumed that they wanted the decimals. A new vaccine was tested to see if it could prevent the ear infections that many infants suffer from. Babies about a year old were randomly divided into two groups. One received vaccinations, the other did not. Following year, 335 of the 2,455 children vaccinated had ear infections compared to 506 out of 2,453 unvaccinated. Okay, so randomly divided into two groups. Less than 10% of the population sampled, independent, and more than 10 successes and failures in each group. All of that's true. All right, so the unvaccinated needs to come first. So that's this proportion. Okay, so we're going to go to stat, tests, and we're going to go down to the 2 proportion Z interval. And it's 506 out of 2453. 506 out of 2453. And then 335 out of 2455. And we want a 95% confidence. So do not round until the final answer, then round to 1 decimal place. So 0.0. They put a percent sign after it. So I need to move this over 2 places. So 4.9% to 9.1%. Use your confidence interval to explain whether you think vaccines are effective. Okay, so this does not contain 0, right? So the one that came first was bigger. So the unvaccinated group had more ear infections. We are 95% confident that the rate of infection of vaccinated babies is higher. Nope. We are 95% confident that the rate of infection is lower. Huh? We are 95% confident that about, no. So let's try this. We are 95% confident that the rate of infection is lower by an amount from 4.9% to 9.1%. This is a meaningful reduction considering the 20% infection rate among unvaccinated babies. A new vaccine was tested to see if it could prevent the ear infections that many infants suffer from. Babies about a year old were randomly divided into the two groups. One group received vaccinations, the other did not. The following year, so a positive 99% confidence interval for the difference in rates is this. Suppose we had conducted a hypothesis test. All right. So we believe that the vaccinated should be lower than the never vaccinated. So vaccinated would be, if you move this to the other side, would be lower than the unvaccinated. So that's true. State a conclusion based on the given confidence interval. This does not contain 0. So we would reject the null hypothesis. Vaccination reduces ear infections. What alpha level did your test use? If this was 99% confident, then that's 0.99. So 1 minus 0.99 will be 0.01 or 1%, right? Because it's a percentage. So move the decimal over and it'll be 1%. Divided in half. I forgot to divide in half. So it would be 0.5%. Half of the 1% that's left. If our conclusion is wrong, which type of error did you make? So we rejected when we should not have. That's a type 1 error. Rejecting the null hypothesis when you should not have. What would be the consequence of such an error? We would have vaccinated a bunch of babies that didn't need it. Okay, 1 month before an election in a metropolitan area, a poll of 660 randomly selected voters showed 53% planning to vote for a certain candidate. A week later, it became known that he had shared inappropriate pictures of himself, and a new poll showed 50% of 1090 voters supporting him. Do these results indicate a decrease in voter support for his candidacy? All right, P1 is the proportion of voters planning to vote for the candidate in the first poll, and P2 in the second. Should be that they're the same, so we can rule out A. And then we think that P2 would be lower. So if I move this to the other side, see P2 would be lower. Determine the test statistic. So we're going to go over here, stat, tests, and now we're doing a 2 proportion Z test, option 6. So this was 0.53 times 660. So 350 out of the 660. And this one is half of 1090. So because it's 50%, so half of it. thought P2 was going to be lower. All right, so our Z is 1.23. And the p-value is right here, 0.10, so 110. And we would fail to reject. Right here, right? Because this is not bigger than an alpha value of like 0.05, right? If our conclusion turns out to be wrong, so we failed to reject when we should have, that would be a type 2 error. If you concluded there was a difference, estimate that difference. But there's not, because we're not, this is not statistically significant. So we don't want to do a confidence interval here, because I'd only do that confidence interval if I thought a difference existed based on the hypothesis test. Researchers comparing the effectiveness of two pain medications randomly selected a group of patients who had been complaining of a certain kind of joint pain. They randomly divided these people into two groups, then administered the painkillers. Of the 116 people in the group who received medication A, 82 said it was effective, and the other group, 63 out of 113 said it was effective. Complete our parts. Okay. So we want a 95% confidence interval for the percent of people who may get relief from this kind by using A, medication A. So let's go over here to stat tests, and we're doing a 1 proportion C interval on medication A. So medication A was 82 out of 116. And we wanted a what confidence level? 95. So, okay. We are 95% confidence based on this study that between how many decimals? 1 decimal. 0.6 and 0.8. Now, by the way, I'm not using this one because I know how many people in the study found it helpful. I'm trying to generalize to a larger population. So the wording is wrong in B because it's not about the study, right? And then this doesn't even make sense. So just, what? So I'd round to 1 decimal place. Oh, percentage. My gosh. Okay, 62.4%. I didn't catch the percent sign. And 78 so 79%. I just needed to move the decimal over 2 places and round to 1 decimal point. But now we're going to do it for medication B. It's also 95%, and we're going to do the same thing. So we're going to the 1 proportion C interval. Medication B is medication B is 63 out of 113. It's also 95. So 46.6. And 64.9. Okay, so now do these intervals overlap? Yeah, look, see, this starts at 62 and this goes to 64. So between 62.4 and 64, there is an overlap. Okay, so there we go. Yes, they overlap. This might indicate that they're just equally effective, but we haven't done it properly, right? We would need to do a difference in proportions. All right, so now let's do that difference in proportions. So we want to go to stat, tests, option B. And our first one is 82 out of 116. And our second one is 63 out of 113. All right, by the way, I did A minus B. So these are both positive, so A would be bigger, right? So we are 95% confident that the proportion of patients who find A effective is 2.6 to 2.7? No, 27.3. Yikes. That's bigger. Higher than the people who will find B effective. Does this interval contain 0? No. So that means there is a difference in the effectiveness of the medication. So notice that the point of this problem was if you look at them individually, you're not running the same test as looking at that difference. So you may get the wrong conclusion. Our second approach is the wrong approach. So to find the variability in the difference of proportions, add variances. The 2-1 sample intervals do not. The 2 sample method is the correct approach. A study of home ownership rates of single men versus single women reported a 95 confidence interval to be this. Okay, can we conclude there is a difference in home ownership rates? Nope. Why not? Because 0 is inside this interval. On a final project in an introductory statistics class, the student reports a p-value of 0.0893. She states there is an 8.9 per 3 chance that my null hypothesis. No. This is the probability of getting a sample as weird as you got if the null hypothesis were true. It's not about the validity of the null hypothesis. When do we pool our populations and use the formula for the pooled? When it is assumed that the 2 populations are really the same. Okay, guys, that is the end of the chapter 21 homework. I will talk to you in a bit. By the way, make sure you click up here and get your points for these. And let me know if you have any questions.